Hello students, in today's lecture I will discuss about Cohen Sutherland line clipping algorithm. As I have already discussed in the previous lecture about the clipping, clipping means displaying a certain portion of a picture. That means, for example, if you are having any object and if you want to display some of the specific uh, position of an object, then in that case you have to perform the clipping. And we are having various types of clipping that we have already discussed in the last lecture. Now in this video I will discuss about line clipping. For line clipping we are having a famous algorithm that is called as Cohen Sutherland line clipping algorithm. It is the oldest, most popular and efficient line clipping algorithm. It reduces the number of line intersections that must be calculated by performing initial test and speeds up processing. In this, every line endpoint in a picture is assigned a 4-digit binary code called a region code. Region code identifies the location of a point relative to the boundary of the clipping rectangle. So, as the name suggests, this algorithm was developed by Cohen and Sutherland. And basically in this you can see that we are performing clipping on the line segments, and what is happening in this algorithm, each endpoint of a line is assigned a code, and this code is known as region code, and after that we are performing some calculations. Now you can see in the figure, this is a window, and if any line is lying completely inside this window, then both the endpoints of the line will lie in this window, and the 4-bit region code for both the line endpoints will be 0000. And you can see that this is the window, and we can see that the left portion of the window is intersecting at x-axis as well as on the y-axis. So this is xw minimum, this is xw maximum, this is yw minimum, and this is yw maximum. This we have already discussed in the point clipping. And what is happening, initially we are drawing any object on the world coordinate system, and in this, whatever the portion of an object is falling within the window, we are displaying that portion, and the portion which is outside the window, then we are not displaying that portion. So the world space is divided into regions based on the window boundaries. Each region has a unique 4-bit region code. Region codes indicate the position of the regions with respect to the window. So this is the code format. In the leftmost bit, it is representing the left portion, then the second bit is representing the right portion, then the next bit is representing below, and this portion is representing above portion. So you can see that this portion is neither it is in the left, nor it is in the right, nor it is at the bottom, and nor it is at the top. So all the values of bits in this portion will be 0. Now here is a figure which is representing various lines, and you can see that this dashed line indicates the region of the window, and we are having various lines, and you can see that some of the lines are falling inside the window, some of the lines are outside the window, some of the lines are crossing the window, So normally in this we are having three cases. You can see that lines which are completely inside the window, they are completely visible. Lines which are completely outside the window, they are not visible. And if any line is overlapping the window region, then those portion which is inside the window will be kept for display and the remaining portion will be rejected. So every endpoint is labeled with the appropriate region code. So the first step of the algorithm is that whatever lines you are having, you just label the endpoints of the line with the 4-bit region code. And you can see that the line P5, P6, for this line, both the endpoints are inside the window. So the 4-bit region code for P5 is 000 and for P6 is 0000. Now we are starting from the case 1, and in this region we are considering those lines which are completely inside the window. Lines completely contained within the window boundaries have region code 0000 for both endpoints, so they are not clipped. That means this line will be kept for display. So in case 2, in this we are having the lines which are outside the window, and for these lines one bit is common. One or more than one bit is common. So whenever you are taking AND of these two endpoints, whenever you are applying AND operation, then definitely you will not get 0000. So what is happening? We are performing AND bitwise AND operation of the endpoints. If we are not getting 0000, then in this case the lines will be clipped. That means these lines will not be visible on the output unit. So we can see that line P11, P12, line P13, P14, these two lines are invisible and they will not be displayed on the output unit. In case 3, lines that cannot be identified as completely inside or outside the window may or may not cross the window interior, and for those lines the bitwise AND will be 0000. So you can see that in this case we are having a line which is overlapping the window. Some of the portion of the line is inside the window and some of the portion is outside the window. So if you are taking bitwise AND of 0000 and 0100, then definitely you will get 0000. And if the bitwise AND of both the endpoint is 0000, then in that case the line will be partial visible. So in this case, consider the line P9 to P10 below. Start at P10. So what is our objective? Our objective is, for example, if you are having any line whose endpoint is having value 0100, so what we have to do, we have to make this 1 as a 0, and for that you have to find the position of this 1. So you can see that the position of this 1 is, it is at this position, that means at below. That means the line segment is obviously, it is intersecting at which position? It is intersecting at YW minimum. So you can see that at this point we are having the value of Y and we need to calculate the value of X. For that, what we will do, we will simply use the equation of the line and find this intersection point. From the region codes of two endpoints, we know the line does not cross the left or right boundary. Calculate the intersection of line with the bottom boundary to generate point P10 dash. So you can see that here the value is 0 1 0 0. This one representing, the one is representing that the line is crossing the bottom boundary of the window. So for that we take one intersection point, and the intersection point is named as P10 dash. Now you can see from the figure that the line P9 P10 dash is now completely inside the window. So you can say that in this case, for the line P9 P10, only the portion from P9 to P10 dash will be kept for display. So we can see that intersection points with the window boundaries are calculated using the line equation parameters. Consider a line with the endpoints x1 y1 and x2 y2. The y coordinate of an intersection with a vertical window boundary can be calculated using y is equals to y1 plus m x boundary minus x1. So we are having a line equation, and you know that equation of line is y2 minus y1 is equals to m into x2 minus x1. So we are utilizing that equation, and if we are having any x value, we are having the initial point of a line which is x1 y1, and we are having the x value at the boundary, then we can easily calculate the value of y. But if the reverse is the case, we are having the value of y and we want to calculate the value of x, in that case we can apply equation as x is equals to x1 plus y boundary minus y1 upon m, and we know that m is the slope of the line, and it is given as m is equals to y2 minus y1 upon x2 minus x1. So this is all about the clipping, and in this video we have discussed about Cohen Sutherland line clipping algorithm. Thank you.